Thank you everybody for joining our call today. My name is Rihab Kordan and I work as a Senior Business Analyst at Certera. I am also a member of CDISC, SENT, PC, PP, and ADAM teams. Today is part one of our two-part webinar series to address roadblocks when creating PK domains and datasets. Part two will be on August 19th and will provide a comprehensive overview of how Certera PK Submit technology helps overcome these roadblocks. A registration link to this webinar will be provided at the end of today's presentation. I would like to remind you that this is a 30-minute webinar and you all have been muted. To ask questions during the webinar, please use the Q&A panel at the bottom of your screen, and I will address as many questions as possible at the end of the webinar. In today's call, we will start with some definitions, explore some common roadblocks, such as data gathering, data verification, data processing, and data conversion for both tabulation and analysis datasets. We will summarize all the necessary steps to a successful creation of domains and datasets at the end of this call. Let's start with some definitions. For CDISC, it stands for Clinical Data Interchange Standards Consortium. SDTM, Study Data Tabulation Model. SENT, Standard for Exchange of Non-Clinical Data. ADAM for Analysis Data Model. PC for Pharmacokinetic Concentrations. PP for Pharmacokinetic Parameters. RILREC for Related Records. ADSL for the Subject Level Analysis Dataset. BDS for Basic Data Structure. ADPC for Analysis Dataset for Pharmacokinetic Concentrations, and ADPP for Analysis Dataset for Pharmacokinetic Parameters. So our first step is the data gathering. We know that the data used for PK analysis are concentration time profiles, dosing data, as well as some additional subject data like weight, age, etc. So they usually come from different data sources with different data structures. If we want the concentration data, sometimes it comes from the bioanalytical data sets, and even in some instances, for the same study, two different analytes they get analyzed in two different labs. So for the same study, we may have two different concentration data sets coming from two different sources. For the dosing information, we usually get it from an ex.xpt, which is an exposure domain in a CDISC format, or other collection systems. Demographics information, they come from the dm.xpt or other collection systems. DM stands for demographics. And the dates and times, sometimes they come from a CRF if a study is a clinical, or other collection systems. For preclinical data. All these different data sets, they need to be merged together to generate an intermediate file and that we can use to calculate our PK parameters. And in order to generate this intermediate file, we need to make sure that each data set has a defined sort keys or sort variables to allow for a successful match between the datasets and therefore a successful merge. Data verification is a necessary step before we proceed with the merge, because we will explore that in the next slide. So for data verification, we should be looking for some missing data, because we know that when we get the BA files or the bioanalytical files, sometimes if a sample was not collected, it just does not get added to the file. The record does not exist. But for SENT or for SDTM, all the samples that are defined by the protocol, they need to be present in the domains. So if a concentration is not measurable or a sample is not collected, it needs to be addressed in two different variables that we will explore in the next slide, called PC stat for the completion status and PC reason. And the PC reason needs to store the reason why the sample was not collected. The second step is to check if all my time points are aligned and belong to the same reference day. Another example, and of course we will explore that in details later, is all the 24-hour time points and above. So let's take the 24-hour time points as an example. We know that the 24-hour is an actual day 2, and it's very important to leave it as day 2, but for analysis or for the FDA's review, we need to align it to be day 1 for an accurate representation of the profile. If we don't do that, we will be missing one time point one time point defined in the protocol, but we will not be reflecting it in our analysis. So, like I said, we will discuss how to handle the 24-hour time points and above as part of data processing. Then, once we've added the missing records and aligned our profile, the third step is data processing. So, for the data processing, like I said, for the missing samples, it's very important to locate them and have special records for them in our data sets. The NS and QNS, these are just examples. Of course, we can have other abbreviations. They need to be addressed in the PC stat, which is the completion status, and PC reason, which is the reason why the test is not done. For the LLQ or BLQ, we know that they come in as character values in the concentration columns. However, for some analysis, depending on each company's rule, they need to substitute them with some numeric values for analysis purposes. And this numeric value, it needs to be clearly communicated in either by the use of QNAM, which is qualifier variable name of PCCalc-N, in the supplemental qualifier for non-clinical data, or in an ADAM dataset for clinical data. The non-clinical data has one extra step that is recommended by the FDA Technical Conformance Guide. I have to mention, though, that these are non-binding recommendations, but they are considered as best practices. So these recommendations need preparation in advance. So once we prepare our intermediate file, we need to account for at least 2 or 3 different columns that will treat the BLQ value 3 different ways. So the Technical Conformance Guide, it states that for the PCORS, if the result is below a limit of quantitation, the PCORS needs to remain as is. It should contain the actual verbatim test results. So as an example, if in the ORS, in the original concentration column, we had a less than sign and 0.5, that's just an example, it should remain as is in the PCORS. In the PC stress C, which is the standardized result in character format, the FDA suggests to use the word BLQ, and this signifies that the result is below the limit of quantitation. For the PC stress N, which is the standardized result in numeric format, we should keep it blank. So it's 3 different columns, or let's put it this way, 3 different treatments for the same results. Other considerations we need to keep in mind while processing the data are the exclusion of outliers. If we are processing some interval data like urine collections, we need to account for the start and end times, or also the interval volume. So now for the aligning the profiles like we mentioned before, Aligning the time points is an important step to perform the analysis and to FDA's review of the domains. So the FDA Technical Conformance Guide states that the PC domain should support creation of time series graphs and automatic calculation of pharmacokinetic parameters from sets of related plasma concentrations. Therefore, grouping each different set of time series measurements used to calculate a related pharmacokinetic parameter correctly is very important. As we can see in the graph here, if we leave the 24-hour time point in day 2, we cannot produce the graph correctly. Therefore, we cannot have all our time points. That being said, the day 2, it's a valid day. It's an actual sampling day. So we need to keep it because we will need it to populate the PCDY, which is the actual study day of specimen collection variable. So the solution here is to create a new variable to align all time points for analysis purposes and for FDA review, and keep the original one to reflect the actual day of sample collection. Some examples of grouping variables. If the study is preclinical, then we can use the PC nom-dy, which is the nominal study day for tabulation. Or we can use PC grpid, which is a group ID for clinical, as the SDGM implementation guide shows the examples. The PC TPT ref, which is the time point reference, would also be an option if it is well defined. Example would be like day 1 dose or day 1 first dose in case the study is dosed twice a day. Another data processing challenge will be merging the dosing dates and times to a concentration data set to populate PCRF-TDTC, which is the date time of reference point. As we know, in the exposure data, we have only one record per treatment event per subject. But in the concentration data, we have one record per time point per reference point per subject. So therefore, we need to locate the corresponding dose, date, time for each profile and repeat it for each time point within the same profile. As you can see here, so we locate the first one, then we keep repeating it for the same profile. Where the necessity of grouping variables, as we mentioned it in the previous slide, if we didn't group the 24-hour with the day 1, we would never be able to copy the date and time of the exposure to that 24-hour time point. The PCRF-TDTC, date time of reference point, can be used with the PCDTC, which is the date time of specimen collection, to calculate actual times if we want to use actual times in our analysis instead of nominal times. And for interval data, we all know that urine collections sometimes are not easy to represent in a standard format. We know that each company has their own interval definitions. So sometimes in a BA file, a common practice that we've seen is to present the interval time points in the nominal time column as 0-4 or 0-4H. So we do not get two different columns for the start and the end time of interval. And we know that these two columns are necessary for analysis, as well as the definition of the evaluation interval in the PC domain. Another common practice is to have the volume unit, which I didn't show in this example, but we've seen that the volume unit, it comes either in the column header or in the same cell as the the urine volume. So example would be in the urine volume column itself, the value would be 50 space ml. And it is very important to have values and units in two different columns because we will map them in different, later for sand, we will map them to two different variables. The volume variable is an important variable to calculate the urine PK parameter. Therefore, it needs to be submitted in the PC domain as values of PC test CD, which is pharmacokinetic test short name, but in separate rows and not in separate columns as this example is showing. So in this example, we have the volume come in as column, but once we need to process it to be a PC domain, we need to transpose the volume to be a row. So it's a bit challenging, but it's feasible. Once we have updated and processed all the necessary data, we will need to add extra variables that we will need for our analysis. Is subject level data. Sometimes it comes from different sources. Even though these sources are one subject, are one record per subject, like the DM demographics or ADSL for subject level data, the data needs to be copied for all time points, occasions of the same subject. As we can see here, we take the same value and we repeat it per subject. So it's very important. We can also add the plant treatment dose from the ADSL. This is a very important information for analysis. And we bring in sex and arm from ADSL or DM. These are just examples, but we can bring in all the necessary information from different domains. So once we make sure that we have all the data, we have the following considerations, and it's very important to ask these questions. What are the domains or data sets to create for PK data? This is a very important question because it will drive how we are going to use our intermediate file to generate all the necessary domains or data sets. If my study or if I am in the preclinical world, we know that for tabulation, I will need to create a PC.xpt, a supplemental PC. Like I said, in the preclinical, a pool def will be necessary, a pp.xpt, supplemental pp.xpt, and a real rec. Why do we need to ask these questions? Is to define how I will convert my data to make it compliant and to avoid some validation issues. The next question would be, do we have all the necessary data to generate these domains? What are the required formats, control terms? Something to mention here, though, is for the PP and supplemental PP. After we run our analysis, our NCA analysis, the same process gets applied to the PK parameters. I check for missing calculations, why this parameter was not calculated, and I need to address it in the PP domain. So it's exactly the same process. Some examples of common validation issues would be we do not include a required or an expected variable. We will go through this in details in the next slide. Or a variable does not get the control terminology that it needs, or the format compliance is not satisfied. It's very important to comply with the implementation guides and to populate the variables correctly. one more step, one more thing to mention here, it's about the RealRec. We know that each set of PK parameters is related to a specific set of concentration time profiles. It's very important to reflect this for traceability. So we usually use the PC ID, which is the group ID, and the PP ID, which is the group ID in the PP domain. Even though the two variables are permissible, but really they are key variables if we want to create a RealRec domain. So for tabulation datasets, as I show in this slide, the implementation guides for both SAND and SDTM facilitate the building of domains, since both guides list the variable name, variable label, the data type, and the control terms and core variables to be used. In this example, I highlighted the required and expected variables in red just to show you how to locate them. So the data type, first of all, the variable names and labels in our domains need to be exactly the same as the ones defined in the implementation guides. It is very important to make sure that in the variable labels, we have no extra spaces or they follow exactly the same label that is present in the IG. If we have only one extra space, that's just an example, you will have a validation error. So it's really important to make sure to follow the implementation guide. Same thing applies to the control terminology. If a variable says, and this is an example, this PC or as you, if in this column I have the mention that I should be using PK unit code list, if I don't use one of these PK unit code lists, I will be flagged by a validation error. So it's really important to follow the implementation guide. Same thing applies for the type, for the data type. If a variable needs to be character, we need to build it as a character. If it needs to be numeric, we need to build it as a numeric. Also, the three categories defined in the core column are required, expected, permissible. A required variable must always be included in the dataset and cannot be null for any record. If we do that, we will be flagged by validation systems. An expected variable, it must be present in each submitted dataset. Even if the values are null, we will need to document why the values are null. A permissible variable, it should be used in a domain as appropriate. We don't have to include it, but if we have the data for it, it's nice to have. It's really important, again, I'm going to stress on that, it's really important to follow the implementation guides and make sure that all required and expected variables are present in our domains. For the analysis dataset, it's more flexible than the tabulation datasets. The analysis datasets, they have two main data structures. Subject level analysis dataset, which is ADSL, and this is one record per subject, and basic data structure, which is BDS. The BDS would have one or more records per subject per analysis parameter per analysis time point. The ADAM implementation guide defines the ADSL variables and a list of standard basic data structure variable. It does not define which variables each basic data structure must contain, like the SDTM or the SAND implementation guides do. So it's more flexible and it allows for different analysis methods. Depending on the analysis type method, we may use one set of BDS variables in one study and a different set in another study. An example of that would be a parallel and crossover studies. Naming convention is, so we do not have a defined name for analysis datasets, but we have a naming convention. So the naming convention is to prefix each dataset by AD. Then we use the domain name just for more traceability. So it's ADPC for analysis dataset for pharmacokinetic concentrations, and ADPP for the parameters. The BDS dataset is usually a combination of some ADSL variables, SDGM variables for traceability, which is the main concept of analysis datasets, and also we can add some. We have to add some standard BDS variables. I need to mention here that at least one treatment variable is required in a BDS dataset. We can have it either from ADSL, TRT-XXP, or the record level treatment variable like TRTP. The TRTP stands for planned treatment, and TRT-XXP stands for planned treatment for a period XX. Some examples of BDS variables that can be used for ADPC, ADPP. We can use a visit, which is the analysis visit, and we can derive it from the visit variables from both domains. ATPT, ATPTM for the analysis time points and analysis time points in numeric format. AVAL and AVAL-C for the analysis value and analysis value in a character format, which we can derive from PC stress N or PP stress N, and param and param CD, which is the description of analysis parameter. I have to mention here, though, that for the param, it must include all descriptive and qualifying information relevant to the analysis purpose of the parameter. Why I was stressing on having the unit in a different column, because in the param for both datasets, either ADPC or ADPP, the param name needs to include the unit in the description. So it's better to have them defined before for an easy use at the end when we create our analysis datasets. So, and the key steps here, I've defined them in 6 steps. The first one is to identify the required and expected variables for each domain dataset depending on the standard used. The second step is to verify that data is available in the source dataset to populate the required and expected variables. If the expected variable is null, we need to make sure that we document why it's null, either in the study data reviewer's guide or in the defined files. Step 3 is, if I have data available for permissible variables, we need to populate. So we list all the permissible variables and look at the merged data set to see what has been captured but not yet mapped to a required and expected variable. Step 4 is, we know that the GRP ID, which is the group ID variables, are permissible in both standards, SAND and SDGM, but they are key variables to relate PC and PP domains. Step 5 is the remaining variables should be mapped to related domains, such as CO or supplemental PC. The supplemental PC, the BLQ would be a good candidate to go to supplemental PC, the BLQ substitution. And step 6, and that's the very important one, is to follow the SAND SDGM ADAM implementation guides to build the domains or datasets to avoid any validation issues. And this, well, I hope you enjoyed this webinar. Please join us on August 19th at 11 a.m. Eastern for a demonstration of how PK submits. A plugin to the Phoenix platform easily overcomes roadblocks when developing preclinical SAND and clinical SDGM datasets for a regulatory submission package. New enhancements will also be reviewed, such as the ADAM dataset creation for SDGM and supplemental qualifiers files for both SAND and SDGM. So this concludes my webinar, and I will be taking some questions. Anna, do we have any questions in the Q&A?
Yes, we have a couple of questions, and please, if you have a question, you can type it in the Q&A panel right on the bottom. You might have to go through the circle with 3 dots to find that panel. Okay, so first question is, could you elaborate regarding using the sub-PPC to specify BQL handling and actual times.
Okay, the supplemental PC is, we use the variable QNAM, which is PC calc n. We need to make that's for handling the BLQs. This is really very important for the FDA to review and to know what substitutions were used. In the PC calc n, we list only the substitution values. We don't need to list all the concentration values. If, let's say, you have sequence 1 or sequence 2 were substituted, then in the supplemental PC, we create a QNAM called PC calc n. We give it a 0, and we reference the right PC sequence in the PC domain. For the actual times, is the same thing. If we calculated actual times or we used actual times in our analysis, it needs to be clearly communicated in the supplemental PC, using the same process, I mean. If your study is preclinical, but if your study is clinical, then you would address the actual times in an ADAM dataset.
Okay. We have a couple more questions, but we won't have time to address them today. We will be sure to send a Q&A with responses with the recording of the session. And there's a question about PK Submit that we can also address in the next webinar.
Sure.
Okay, so Rihab, do you want to just adjourn with your last slide?
Yes. So this is the end of our time. Thank you for attending. This webinar has been brought to you by Certera University. Please visit us to learn about more about training opportunities for your professional development in the PK/PD area. Thank you.
Thank you so much. We will adjourn now.
Thank you.